Okay. So now I am going to be taking you through this past exam paper where we will look at question number 3. So I'm pretty much sure that you are interested in seeing how we do this type of questions which involve the tan functions where asymptotes are involved. Okay, so we will definitely not waste much of our precious time, and we'll get started with question number 3, whereby we are given a statement there which says the following graphs have been drawn below for that interval, meaning drawn from 0 degrees up to 360 degrees. We've got f of x, which is equals to tan x, and g of x, which is equals to a sin x, that is added to q. Okay, then it's fine. I think everything in that statement, it makes sense. What matters the most is for you to be able to identify which graph is f. So the graph of f, it is that one for tan. So you can see next to that line, they indicated f. So even if they just indicated it once and not there and there, you will still be able to know that that line, it is for the function of f. Then for the function of g, you can see it is that one. So it looks like they made an extra effort to make sure that all the lines that belongs to f, they label all of them. I'm just saying, even if it was labeled at one line, you would know that those other lines are for the tan function. Okay, then it's fine. Let's see if we can be able to answer this question. So they want you to use the graphs to answer the following questions for that same interval where they drew from 0 degrees to 360 degrees. Okay, so now the first question, what they want you to do, it is to determine the value of A and Q. Where is A? Where is Q? So it looks like A, it is that one over there, and Q, it is that one over there. Both are for the function of g of x. So that one of g of x, the A value, if you remember, I said the safest way, it's for you to use that formula that I've just shown you, where you just take the maximum value and that minimum value, you add them together, and then you have them. So that means the A being the amplitude, it should be half of maximum value being 3. You combine it with the minimum value, which is 1. Definitely inside, you've got 4. So that means half of 4 equals to 2. That's how you get your A value. So that means already we do know that, okay, g of x, it is actually g of x equals 2 sine x, that is added to q. Can you see? Something of this nature, the honorable member, it makes it easier when you use this formula. You will never be confused. It may be worked out differently or in a different way, but on your side, you should just always know that the safest way to work out the A value, it is that. Sometimes they can calculate it differently, but this is the safest way. I just wanted to emphasize that point. So now we need to find that value of g. So that value of g, remember, g of x, in other words, it simply means y. So this thing is the same as y equals 2 sine of x plus q. The reason why they say g of x instead of y, it's because you have more than one function. So we have to give them the names so that when we want to ask you about that one, we won't make it obvious and say based on tan x function, but we'll just say for f of x, then you know it refers to that one of tan. And if we want to ask questions on that one of g, we will therefore say g of x, then you know we are talking about the sine graph. That's why they are given names. But otherwise, just know that that g of x is the same as y, or it means y. F of x, it means y. So it's like it is y, but for the function of f. It is y for the function of g. Just interpret it in that way. So that when I'm going to explain to you how you get the g value, it will therefore make sense. So for that one of the g value, you will therefore need a coordinate. You can use the coordinates that you can use. I think there are many because you've got a point there that has the coordinates where x, it is 0 degrees, and then you've got 1. You have a point there. Remember, we are focusing on g, not f. And then for the coordinates of that, you have x being 90 degrees, and then that one being 3. So that point you can still use. Which other point is obvious that you can use? Even this one is another obvious point that you can still use, whereby we have 270 degrees, and then y, it is -1. Can you see? So another point, even though it's not obvious, you may need to know it when you, or if you are experienced, it is that point there. It is that point there. I'm sure you would agree with me to say that point, based on our experience on this topic, that's where we are having that being 180 degrees, and then that being 1. Can you see? That's how an experienced person is able to identify the obvious coordinates. Another obvious coordinate, it should be this one, whereby there we are having 360 degrees, and then we are having y being 1. So these are the points that you can use in order to calculate q. Because how you use those, let's say, for example, we use this point name. So how you use it, that means where you see your y, you are going to put 3. And then where you see your x, you are therefore going to put 90 there. Then you solve for q. That's how it works. So let's see. It's like you are having 3, which is equals to 2 sine of 90 degrees plus q. So let's punch 2 sine 90 degrees. What do we get? 2 sine 90 degrees. It gives us 2. So when you take 2 to the other side, it will therefore become 3 minus 2, which is equals to 1. So it's like q equals to 1. Something of that nature, the honorable member. You just need to be very careful in terms of how you work it out. Let's see. Even if you may decide to use that point as an example, if you use that point, that means your y for that one, it is 1 equals to 2, but the angle you put, sine of 360 degrees plus q. Then if you punch 2 sine of 360, let's see, 2 sine 360 degrees, it gives us 0. Can you see? So you have 1 equals 2, 0 plus q. 0 is nothing, then it means 1 equals 2 q. So you can still try again by using that point, and try again using that point. And not only that, you can still try again using that point. You should arrive at the same conclusion. I hope that part makes sense, the honorable member, in terms of how you calculate that. Look at that. It's just allocated 2 marks. Not that it's complicated. Okay, let's not waste time and say, write down the period of f. Which one is f? We still remember f is that one of tan. So what we know is that the one for tan, the period, we do have a formula which says 180, not 360, but 180 degrees that you divided by the b value. B value is 1. So we have 180 that we divide by 1, That's why we end up getting 180. Remember the 1, which is that one that I said it actually lies between that trig name and the angle. So in some instances, at a later stage or in the coming years, you'll find that we add something there. But just be aware that, or let me summarize to say, when you are in grade 10, your B value will always be 1. So that's what makes it easier. But as you grow and you get to higher grades, then it may change. So let's see. Write down the range of G. Now we need to go and look for G. Remember, what makes the range? It is the minimum and the maximum. So the minimum, it is that -1, and the maximum, it is that 3. So that means the range, it is the one that we use to find the amplitude. So that means, if you remember, you've got many ways in which you can write it down, and that -1 and then 3. Or you can just say -1 between, and then that. So meaning between -1 and 3. Yes, I'm correct in saying that, because we are talking about this function of G, which is just fluctuating within that range, not outside of that, but within that range, something of that nature. Look at this question. Write down the values of x for which f is undefined. In other words, they are simply saying, write down the asymptotes for the function of f, because that's where we get the errors. Where is that? So we can see already that we are having dotted line. We are having a dotted line where that x value is, it is at 270. So that means those values, it should be x, which is at 90 degrees, and again x at 270 degrees. Something of this nature, the honorable member. And there is another question, the last one, where they say, determine the values of x for which g of x equals to 1. So we now need to look for the values of x whereby g equals to 1. Indirectly, I think I've answered that question. Let me just erase all of this so that at least it's going to be clear as I explain this question, and you will realize that I have actually indirectly answered this question in the beginning. So what I'm doing now, it is to actually erase all these. I just want to make it clear there, so that at least as I explain, we are on the same page. Okay, so we are concentrating on the function of g, name. But we are looking for the x values whereby g is equals to 1. So that means we are looking for the x values whereby that g is equals to 1. The first x value, it is that one, whereby the graph of g equals to 1. There is another one, whereby g is along that line of 1. And there is another one, whereby that graph of g is along that line of 1. So it's like on this function, we are just trying to point out the values whereby whereby y is equals to 1. I've just indicated to say it is that one whereby it's 0 degrees. That's why we have 1. Another one, it is that one whereby x is 180 degrees. That's why we have 1. Then we have 1. So that means x value should be 0 degrees. We've got another one at 180 degrees. We've got another one at 360 degrees. That is where g of x, remember g of x, I just said it is the y value. So those are the x values whereby y will give you 1. I'll try to say not that one, but that function of g. You can substitute, for example, 1 there, and then check what you get as an answer. You already know the formula is 2 sine x, I think it's plus 1. Then you put a 0 there, you'll see it'll give you 1. You put 180 there, it'll give you 1. Put 360 there, it'll give you 1. So that's how it works. I'm pretty much sure that you understood what I was doing there. I hope that part made sense. For that reason, leave it here and say until we meet again.